In this next video, we're going to be looking at a permutation formula. But before we get there, let's review over what a factorial is. And so definition for that is for any positive integer n, the product of the integers 1 to n. And this is written as n factorial, or n with that exclamation point, is equal to n times n minus 1 times n minus 2, so on and so forth until 3 times 2 times 1. And a special case that we have is that 0 factorial is equal to 1. So for example, 4 factorial, this would equal to 4 times 3 times 2 times 1, which is just equal to 24. And so that brings us to our two formulas. So the number of permutations of n objects is given by this symbol here, which reads nPn is equal to n factorial. So for example, if I had 4p4, the number of permutations of 4 objects, that's going to equal to 4 factorial, which we saw before, which is 4 times 3 times 2 times 1, which is just equal to 24. Now let's say I want to take the number of permutations of m objects taken r at a time. So kind of like in our previous video when we're looking at the ways that we can arrange 2 letters of the word July, that's going to be this case here. And so that is the number of permutations of n objects taken r at a time is given by n factorial divided by n minus r factorial. So for example, 4p2, the 4 is my n, r is my 2, how many objects I'm taking at a time. And so this is going to equal to 4 factorial over 4 minus 2 factorial. Do the parentheses first, and you get 2 factorial. And now we can kind of expand that 4 factorial. And if I expand that, that's really 4 times 3 times 2 factorial divided by 2 factorial. And so I see these 2 factorials cancel out, and I'm left with just 4 times 3, which is 12. So let's look at some more examples of that. So I'm going to evaluate the expression. So first I have 6p2, so that means I'm taking a permutation of 6 objects 2 at a time. And so that 6 is my n, 2 is my r, so this is going to equal to 6 factorial over 6 minus 2 factorial. So I get 6 factorial over 4 factorial. Now I'm going to expand out that 6 factorial because I know there's a 4 factorial hidden in there. And so this becomes 6 times 5 times 4 factorial divided by 4 factorial. My 4 factorials cancel out, and I'm left with 6 times 5, which is equal to 30. Okay, let's look at another one. So here I have 8p0. So now 8 is my n, 0 is my r, and so this is equal to 8 factorial over 8 minus 0 factorial. So I get 8 factorial divided by 8 factorial, which is just equal to 1. Okay, now 13pn, so 13 is my n. I'm taking 9 objects at a time, so I have r is 9. And so this becomes, using my formula, 13 factorial over 13 minus 9 factorial. So I get 13 factorial over 4 factorial. Expanding out that 13, I have 13 times 12 times 11, 10, 9, 8, 7, 6, 5, and 4 factorials. This one is going to be a larger number. So I can cancel out my 4 factorials, and I'm left with all of those numbers multiplied out, which when you multiply it out, you should get 259,459,200. Okay, let's look at one more example. So here we have a word problem. It says 10 horses are running in a race, and how many different ways can the horses finish first, second, and third? And we're going to assume there are no ties. So this is a permutation because order does matter. We're looking at different horses that are finishing first, second, and third. And so I need to see, okay, which formula am I using and how many am I choosing? Well, there's 10 horses in total, so I know 10 is going to be my N. And we're looking to see how many different ways they can finish first, second, and third. So I'm looking at choosing 3. So that means that my N is equal to 10 and R is equal to 3. So I want to find 10P3. And so plugging that into my formula, I have 10 factorial over 10 minus 3 factorial, which is equal to 10 factorial over 7 factorial. So I have 10 times 9 times 8 times 7 factorial over 7 factorial. And I see that my 7 factorials cancel. And I'm left with 10 times 9 times 8, which is equal to 720. So there are 720 ways for the horses to finish first, second, and third.